Today we will be learning about boiling point. Our essential question is what is boiling and how does elevation on Earth affect a liquid's boiling point? Before we begin, make sure you know the following vocabulary. Temperature is a measure of how fast molecules are moving, kind of like a speedometer. Pressure is continuous force exerted on an object. Elevation is the height above sea level. Before we begin, pause the video and watch the video at this length. Tell me how the phenomenon in this video is possible. So, how do you think it happens? Boiling is the rapid phase change of a liquid becoming a gas. So, during boiling, bubbles will rise to the surface of the liquid because they are less dense than the surrounding liquid. Remember, gas is less dense than liquid. So, what gives a bubble its shape is the internal vapor pressure pushing outwards on the walls of the bubble. If there's not enough energy to maintain the vapor pressure, the bubbles will burst and the surroundings will crush them inwards. Now, what happens at a liquid's boiling point? Well, boiling happens when the vapor inside the bubbles of a liquid is energetic enough to continuously push outwards until the bubble reaches the surface of the liquid. In other words, the boiling point is when the vapor pressure is really strong to the point that it can overcome the pressure of the surroundings or the atmospheric pressure. We call the boiling point a specific property of matter, meaning different substances have different boiling points. We just said that in boiling, the vapor pressure overcomes the atmospheric pressure. So, how does atmospheric pressure change with elevation changes? Well, if we look down close to Earth, there's a lot of atmosphere above us, so there's a lot more air and a lot more pressure. However, up high, like on Mount Everest, there's less atmosphere above you in order to push you down. So there's less air and less pressure. Make sure to do the do section and draw your air molecules. Let's look at a real-world example. The 1968 Summer Olympic Games were held at a very high elevation, 2,240 meters above sea level in Mexico City. How do you think this would affect the athletes and events? Well, at high elevations, there's less air molecules, less air pressure. So that means that there's less oxygen in the air for the athletes to take in. If the athletes weren't careful, they could have had a lack of oxygen. Now, pause the video and watch the video linked. Fill in the data in the picture. So boiling water on Mount Everest in Nepal will tell you the different elevations as well as what their boiling point is. You do not have to watch the whole video, just click ahead to the timestamps I gave you and write down the new elevations. So, what happened to the boiling point of water as the team climbed higher? And how would this affect the amount of time the hikers would need to cook their food? Pause the video and make sure you answer both of these questions. Next, we look at what happens to the temperature and heat energy of a liquid as it's boiled. So, let's start off with a liquid and we're going to heat it up until it gets to the boiling point. At the boiling point, heat energy is being used to break the bonds of the liquid molecules. It's not being used to speed up the motion of the molecules. Therefore, while heat energy is still increasing at the boiling point, the temperature is not. It plateaus or stays the same. It is only after a substance is done boiling, so when all the particles are in the gas phase, that the heat energy will once again be used to speed up the motion of the particles, increasing the temperature. Now, pause the video and do the do section. Put a dot on the boiling point and label it. Circle the plateau during which the water is boiling. Now, look at your page and try the Sum It Up questions. Make sure you check your answers with me before you move on.